Good morning, everyone. We're going to be focusing in on solving trig equations today. And the video you're supposed to watch yesterday, talked about how do we solve trig equations within the given domain. So when x is between 0 and 2 pi, now notice these answers are in radians, so our answers have to be in radians as well. If it was from 0 to 360, then our answers would have to be in degrees. Our goal, anytime they say solve, our goal is to isolate the trig function by using algebra or factoring. And Miss Dwyer went over multiple ways to do that in different examples in the last video. So our goal here is to isolate the secant of x. Well, to do that, I have to get rid of the square root of 3. So then I have secant of x is equal to 2 square roots of 3. Now, the more practice you get here, the better it's going to become. But right now, how do we solve secant of x? Well, this deals with our reciprocal identity. And we want to think of, okay, well, if I have the reciprocal identity, the reciprocal of secant is cosine, right? Because 1 over cosine is equal to secant. So if I flip this upside down and I have 1 over secant, that's equal to cosine. So what we're going to do is we're going to flip this upside down. So it tells me to figure out when is cosine equal to 3 square roots of 2. And then what we're going to do is think of our unit circle. And we got to think of when is cosine, which, by the way, cosine is always the x value. So when is the x value equal to square root 3 over 2? So that would be going over kind of that longer triangle. And I got to think of when is the square root 3 over 2 equal to the x value. And that's in this location right here, which, by the way, this is the longer triangle. So this is a 30 degrees, or pi over 6. Right, so one of my answers is pi over 6. The other answer is when else is cosine positive? Well, if cosine is the x value, that means I'm moving to the right. So anything in here would be when cosine is negative. So the only other answer is if I reflect this point down, and I'm at the spot square root 3 over 2 and negative 1/2. So the only thing is the y value turned negative, but notice x is still positive. Well, this value is 1 less than, so 1 pi over 6 less than 2 pi over 2 pi. So there's a couple ways to think about this. If I'm thinking in terms of pi over 6, well, pi is 6 pi over 6, and then 2 pi, well, 2 pi is the same as 12 pi over 6, so if I'm going 1 pi over 6 less than that, I would be at 11 pi over 6. And those are my two answers for when the secant, the original secant value, is equal to 2 square roots of 3. Notice how I didn't bring the square root up, because I know if I'm dealing with the reciprocal identity, I'm going to flip these around, and that's going to make this a little better. So that's what we're doing today. It's not easy. It takes a lot of practice, and if you did not watch the video, you might be rather confused for quite a while today. The good news is we're going to keep doing this. We're going to keep going over it to build up your confidence. However, we're going to introduce different methods for solving. And when we say that, anytime you hear the word solve, you are thinking, my goal is to isolate the trig function. I'm either going to use regular algebra or some type of factoring to help me out to do that. Okay? So let's look at another problem here. And you might recognize this from the video a little bit. It's very similar. Right away, solve the trigonometric equation from 0 to 2 pi. So my answer has to be in radians. And I notice I have a squared value. When I have a squared value, that means my answers are going to be both positive and negative. So I know that I'm going to have answers in all 4 quadrants. So I'll have 4 answers to this, and you know that right away just from the squared. Okay, so I'll give you a second. Go ahead and write this. We're going to work through these together. And I'm just going to put our goal here is to isolate the cosine of x. Right? I want to get cosine by itself. Now, some students like to think of this as solving the exact same problem. Think of it, instead of thinking of this as cosine squared of x, think of this as just an x. And our goal is to get x by itself. So what do? We add 3, divide by 4, and then you take the square root. And that's the same thing we're going to be doing right here. Now, you don't have to show these algebraic steps, but I'm going to because I think it's just good practice. So our goal is to isolate. I'm going to first deal with addition or subtraction, so I'll add 3. And then I have to get rid of the 4. So I'm going to divide by 4 first. Okay? And then my final step is to get rid of this square. So the way we get rid of a square is we can square root both sides. And one of the properties of fractions is you can square root the numerator and denominator by themselves. But you do have to remember, anytime you take the square root, you could get a positive or a negative answer. So that's where we're going to get all 4 quadrants to be present. So I get cosine of x is equal to plus minus the square root of 3 over the square root of 4, which is 2. Now you'll notice something. This is the exact same thing we just did above. Right? I'm going to scroll up here really quick. See how we solved cosine. Cosine of x was the positive square root 3 over 2. We already know these two are going to be my answers. I'll show you that again just to help generate it. However, hopefully you're thinking about that as we do this. Okay? All right, so what are we thinking? Well, we're thinking cosine of x. Cosine is always my x value on the unit circle. So if I draw my unit circle, I got to figure out when is cosine both positive square root 3 over 2 and negative square root 3 over 2. And we knew this was the first location, and that was at a pi over 6. So there's my first answer. Now, it's important to find the first quadrant one all the time, even if you don't need it, right? But in this case, we're dealing with the positive pieces, so here's my first answer. Where else is cosine positive? That was in quadrants 1 and 2, because that's where the x value is positive. So we would go over square root 3, and then I could go up 1/2 or down 1/2. So those are the locations. And then I think it is important to think about how we think about this. Right? This was pi, but if I'm counting in terms of pi over 6, this would be 6 pi over 6. And then 2 pi is really 12 pi over 6. That's all the way around the circle. But here I went 1 pi over 6 less than that, so that would be 11 pi over 6. And let me see if I can creatively do this. So I get one answer in the first quadrant. I get another one where cosine is positive square root 3 over 2. So I have 2 answers from the plus. And then if I do the minus is when the x value is negative, which means I'm moving to the left. So I'm going to have 2 more answers right here and right here. Or just reflecting that over. So if I go over square root 3, negative square root 3 over 2, and then up, That puts me right here at negative square root 3 over 2, comma 1/2. And all that is that's a pi over 6 less than 6 pi over 6. So that'll be a 5 pi over 6. Okay? And then if I reflect this one down, I'm still going over to the left, so I'm going negative x value. And then this just happens to be my y value is negative 2. So here I went 1 pi over 6 past 6 pi over 6, so that would be 7 pi over 6. Okay? And our goals were to figure out when was cosine equal to the negative square root of 3 over 2. That's at 5 pi over 6 and 7 pi over 6. So here's one of the things that could be frustrating on Delta Math is they're going to ask you for all values between 0 and 2 pi. So that's all the way around the circle. You know that if it's a squared value, it's going to give you 4 answers, most likely. And then you just have to write them out. We usually write them in order. I think Delta Math should accept it if they're not written in order. But notice I have 4 answers around this unit circle. So if you miss one of them, let's say you missed the 11 pi over 6 and you had the first 3, Delta Math is going to consider that to be wrong. All right, so just be aware of that and be careful. Now here's the nice thing. Between these two problems that we just did, the solving part, this part right here, evaluating cosine, so once you isolate your trig function, this solving part is the exact same every time. You're looking at for your answers around the unit circle. Sometimes it might say secant, so you have to use the reciprocal identity, but notice we still solved the same way. What's going to be challenging today is how do we isolate that the trig function. So I really want you to focus on that today. All right. So officially, this is 5152 day 2 notes. And our goal is the same, isolate the trig function. All right, so we're going to do a couple more problems. Find all the angles between 0 and 360 for theta that satisfy the equation below, and if necessary, round to the nearest tenth. Well, notice right away, my domain is in degrees, so my answer has to be in degrees. And there may be opportunities, especially if they're asking us to round. We're just going to grab our calculator and do that. Now, here's the way that I think students need to see this. So I'm going to give you a second to write this problem down. Okay, don't write this part, but again, if I'm asking you to isolate the sign, if you really want to, think of it as an x. Right? I've got negative 4x plus 5 equals 3x plus 5. We're going to solve this the same way we would solve any other problem by moving all the x's to one side, or in this case signs, and moving all the other values to the other side. So that's our goal, is to isolate. Now, it doesn't really matter. I'm a fan of trying to get the sign values positive. So I'm going to move the 4 with addition. I'm going to add 4 sign over to the right side. So that'll be 7 sine of theta. Okay. Now, at the same time, I know that the 5s have to join together. So I'm going to take the 5 on the right side and move it over to the left side. But you notice those are going to add up to 0, and those add up to 0. So nothing, I mean, you have to have something on the left side, so I have 0. Well, now my goal is to isolate sine. So now I'm just going to divide by 7. And I end up with 0 equals the sine of theta. So we reached our goal. We isolated sine. Now we have to solve. Well, now this is interesting because when is sine equal to 0? Well, what is sine? Sine is the y value, right? But when I'm equal to 0 or 1, those are the special angles. Those are the 4 special angles that are on the quadrants. So if I go over 1 up 0, I'm right here. If I go over 0 up 1, if I go to the left 1 up 0, if I go down 0 or over 0 down 1, those are my 4 quadrants. And since our answers are expected to be in degrees, we kind of want to just think of, okay, well, what do we have? We've got 0, 90, 180, 270. And then one little note, notice how theta can equal 0, but it cannot equal 360. There's not a line under here. So I'm actually not going to put 360 here. But then the question is, when does the y value, which is sine, equal 0? So when is the y value equal to 0? At 2 spots. And those are my 2 answers. So what is theta? Theta of 0 and theta of 180. And it's a good idea to put the degree symbol. I think Delta Math allows you to just type in the number. Okay. Now notice, we didn't have to round here. We didn't need to use our calculator because it was a friendly number. We are going to look at one where it's not a friendly number, and that will come up, I think, next if I plan this out right. Okay, and please let me know if you have any questions. I'm going through this rather quickly because this is the second time you've seen it due to that video from yesterday. But if you have any questions, please chime in and I can explain something in more detail. All right, this is where it gets tricky. And there were not any questions like this on the video. And that's where we're going to really focus is what happens now when I have a tangent squared and a tangent and then another tangent. I've got multiple terms. 2 of them are alike and 1 of them is different. The squared is different than the other tangents. So we have to think of this a little differently. All right, I'll give you a second to write this down. Okay. You know what? Something just popped up here I want to make sure we talk about. And it's when you have a problem like any of the ones we had here. But if I jump back to this one here where I had 4 answers, let me show you something really quick on Delta Math that I just want to make sure you're aware of. And I'm sure you're probably familiar with this. So if I had a problem like this and I had 4 answers here and I want to type those in, okay, I'm going to just make these up, but let's say I had pi over 3 as an answer. And then the question is, how do I get another answer? You have to hit the plus box. So if I hit a plus, see how that types in or gives me another answer. So then, again, I'm just making these answers up. Let's say it was pi over 2. Then I hit plus, and let's say this one is 3 pi over, gotta make sure I click over. And let's say this one was 3 pi over 2. Okay, and then my 4th answer would be here, and then you could hit submit. So I just wanted to make sure you guys were aware of that notation. If you have more than one answer, you want to hit the plus button to add those. If you accidentally click too many boxes, you can click on the minus, and it'll take them away. So I'm sure you've had to do that in other ones. I just wanted to make sure that was clear. Okay, so let's do this one. And our goal is the same, right? Our goal here is to isolate tangent of theta. Now, what you're hopefully thinking is, you know what? A better way to think of this is 7x squared. And actually, I'm going to have you write this one down. Okay? Officially, they're doing, to be mathematically accurate, I should do this. I should say, you know what? We're doing something called U substitution, because that is a calculus piece. My kids in calculus are actually learning how to do U substitution with integrals. I know it doesn't mean a lot to you, but I do want you to know that this comes up again. So instead of saying tangent, we're going to call tangent U. And so this would be 7 times U squared minus 11U minus 4 equals, so all I did was say there's a U here and a U here. The reason why I didn't use, I guess I could have used X because these are thetas. So if you want X's instead, but if this was tangent of X, you kind of don't want to use the same variable you had. Well, anyways, what we're going to do here is we need to isolate tangent, but I've got U squareds and U's. All I can do is move everything over to one side, because you hopefully are comfortable with the fact that you see that we're going to have a trinomial here. So when I add this together, I get negative 3u minus 4 equals 0. Well, our goal then is to solve for u. Right? But I can't do any kind of algebra to isolate a u and a u squared other than factoring. So I'm going to do some side work here. And I need to think of, how do I factor this trinomial? So we're going to use our box with a circle in it, just like we did in Algebra 1 and Algebra 2, even in geometry a little bit this came up. So I'm going to multiply the corners, and I hope this is a skill you guys are really comfortable with. And then I'm thinking, well, what times what gives me 28, but adds up to give me negative 3? And that's a negative 7u and a positive 4u. Put those in a different color. Right? Those two multiply together to give me the product of the corners, but add together to give me the middle term. So I'll put a negative 7u here, and I'll put a plus 4u here. And then we're just going to factor out. Right? Just like we did before, I can see the top two terms have a 7u in common. The top left term and right term have now they have a 4. You're going to notice here that it might be plus or it might be minus. I'm going to put a plus right now, but I could change that in case things don't work out. And going across the top and the top terms each share a u. And on the bottom, the only thing they share is a negative 1. Now the best part about this area model is that all these terms, you can check your answer really quick. The 7u times u gives me u squared. 4u times u gives me 4u. 7u minus 1 is negative 7u, and negative 1 times 4 is negative 4. So I know these factors are correct. Okay, so that's what we did here, is we factored. And then we're going to use that zero product property, which says each parenthesis can equal 0 So we're going to put them both equal to 0. And you have an option. You could now replace u with tangent, or you can get u by itself. So if I do that, I'll move the 1 over. And then here, if I subtract 4 and divide by 7, I get 2 answers. However, there's a problem. They're in terms of u. We don't want that. Our original problem was written in terms of tangent. So the u just helped us kind of make this part more familiar, right? If I gave you this problem without tangent in it and just the u's, this is nothing new. You could have done this in Algebra 1. But now, the new part is just right here. What is u? U is equal to tangent. So we're going to plug back in. Let's see. I'll just say now replace u with what u is equal to, which is tangent of theta. So when is tangent of theta equal to 1? That's one of our answers. And then the other one is when is tangent of theta equal to -4/7? And these are both fairly tricky problems to solve. So I'm going to pause from how do we solve tangent of 1 or tangent theta of 4/7? Well, this is really the exact same thing we just did up here in the problems. The only difference is it's tangent instead of a sine or a cosine. So if I think of this part right here, my question is when is tangent equal to 1? Well, we want to think when is tangent equal to 1? That's the same as 1 over 1. And notice this is a positive answer, right? So remember that tangent is really sine and cosine. And the only way I'm going to get 1 is when sine and cosine are exactly the same. So if I think of my unit circle, and I think of the only location where sine and cosine are exactly the same, are right at that 45-degree mark, at 45 degrees, or we would call that pi over 4. Just think about that. If sine is the y value and cosine is the x, and I have square root of 2 over square root of 2, that's the same thing, and they're both positives. So I know that one of my answers is at pi over 4. Now I have to reflect this over because we know that there's 2 answers for every sine, cosine, and tangent in the unit circle. Unless it's on one of the quadrantial angles, then it gets a little different. But if it's one of these special angles, if I reflect it over here, watch what happens. Maybe don't write this part. But if I go over to the left, that's a negative square root 2 over 2 and a positive square root 2 over 2 because I'm going over for the x in the negative direction and up for the y. But if I divide these, I don't get a positive, I get a negative. So this is not one of my answers because the signs are not identical. So the only other answer would be reflecting it down here. And I would be at the spot negative square root 2 over negative square root 2. So if I did sine over cosine, a negative and a negative would turn into a positive. So then the question is, what is this? We know that this is a 45-degree reference angle, but how do we think about it? If one of my answers is pi over 4, and I went to pi, a better way to think of pi in terms of fourths is this is 4 pi over 4. So if I go 1 past that, that would be 5 pi over 4. And that is my second answer for this part. So I might highlight those just so those answers pop. We get tangent is positive 1 at pi over 4 and 5 pi over 4. Okay. Now, here's the tricky spot, right? Tangent is equal to negative 4 over 7. We don't have a fraction of 4/7 as either an x or y value on this whole thing. So this is an odd number, or not a familiar fraction. In that case, we're going to grab our calculator, right? And what we have to do is we have to get the tangent over to the other side. And that just goes right back to geometry. Was the first time you learned this. We did in Algebra 2, and we did it earlier this year. This is just to get rid of a tangent. We use the inverse. And then we're going to do this in our calculator. And Ms. Dwyer alluded to this in the video. However, she didn't show the calculator itself, so I just want to make sure we're aware of that. Now, we have to be careful here as well. I'm going to scroll up really quick. Ooh, I'm glad I did. Notice, this original problem asked for the answers in terms of 0 to 360, so they want my answers in degrees, not radians. So I'm going to deal with this part. I got to change this answer to degrees, and I'll do that in a second. But let's do tangent inverse of negative 4/7. Okay, now, here's where you have to be careful. Since our answer needs to be in degrees, you need to go to your mode, and then you're going to go down, and you want your calculator to be in degrees mode because our answer needs to be in degrees. Okay. So once you do that, then go second quit, and now we have to activate the inverse. So that's second tangent button. Notice the -1 there's the inverse, and then I'm going to go negative 4/7. Hit enter, and then here's my answer. Okay. But we have to understand that because we know that there's more than one answer here. And this is actually really interesting. We got to think of coterminal angles. Now, this answer is in degrees, but it isn't positive, it's negative. It's telling me to go down 29.7448813 degrees. Well, that is my reference angle. And we want our answer to be between 0 and 360. So to figure out where this location is, I need to take the 360 and I need to subtract this reference angle. Because that will give the answer in positive values. So then I know that this answer, this angle from here all the way to here is 330.255. And I think they might even, I'm going to go back up here quick, and round to the nearest tenth. So we do have to round accurately as well. So this would be 330.3 degrees. There's one of my answers. But where else is tangent negative? Well, tangent was positive in quadrant 1 and 2, so in quadrants, 1 and 3, in quadrant 2 and 4, we know tangent's going to be negative. So I'm just going to reflect this over the other direction, and I'm going to create a reference angle of 29.77 or 748813. And then I have to find this location. Well, this location is 29 degrees less than 180. So if I do 180 minus 29.74488813, then I know my answer is 150.25. And we know we're going to round that, so I'm going to round that to 0.3 right away, just so I don't have to rewrite anything. All right, so those are my answers. And like I said, I actually got ahead of myself here, and I accidentally wrote the answers in radians. So they wouldn't give me this answer in delta math because they wanted it in degrees. So all that means is I have to then convert. And the nice thing is you can probably just do this in your head. Well, pi over 4, we knew that was 45 degrees. So there's my answer for pi over 4. And then 5 pi over 4 is a 45 degree past 180. So if I do 180 plus 45, that's 225. So I'm going to move that highlighted part to right here. And now you can see I've got two answers for this portion and two answers for this portion. That's about as challenging as it gets right there in terms of doing the most amount of work. The hard part as a student, I think, is remembering once you find one angle, is there another answer in a quadrant around that that has the same criteria? All right, so we're going to try a couple more just to kind of give you guys some good feedback and make sure you're really comfortable with all this. All right, this one, I can tell you for sure that you will see questions like this in calculus quite often. And the reason why I say that is this is one of the areas where my students really, really struggled in calculus. Okay, so what is it? It's the same question. Find all the angles between 0 and 360. So notice we're in degrees, so our answer should be in degrees. That satisfies the equation below, round to the nearest tenth of a degree. So I've got cosine squared theta for cosine theta. If you don't like this, you could do the u substitution again. I'm not saying you have to do this, but if I have cosine squared, and then instead of cosine I call it u, that means I have u squared plus 4 times cosine, so 4 times u equals 0. Now notice, when we factor, you always want it to be equal to 0. But now I don't have 3 terms, I only have 2. Well, this is the common monomial term. I want to take out a factor away from each of these, and they both have that factor of u. So now, all I did was say I've got u times u plus 4, but each one of these factors, the u and the u plus 4, is going to be equal to cosine. Right? Because now that we know what u is, I can just plug in here, cosine of theta is equal to 0. We can figure that out pretty quickly. And then u plus 4, well, that's cosine of theta. And I could put plus 4 here, but we know we're going to move that 4 over. So why not just do it in one step? I'm going to make a special little note here because this is the part that my calculus kids forget often. We are still calling this factoring. We just didn't use the box with the circle method. We just used the common monomial term. Okay? So now we have to solve. And this one has an interesting result. I got to figure out, when does cosine equal 0? Well, wait a minute. Cosine is always the x value. And whenever I have 0 or 1, those are my quadrantial angles. Right? And cosine is 0, so if I have an x value of 0, that means I'm not moving left or right. That means I'm going over 0 up 1 or over 0 down 1. And those are my two answers, right here and right here. And then we want our answer in degrees. So where is this location? It's at 90 degrees and 270. All right, and then this was something Ms. Dwyer talked about in the video as well. If cosine is the x value, and I'm on the unit circle, the farthest I could go is a direction of 1, right? The radius is always 1, so I could never get out to a -4. The other way you think of this is if you think of this graphically. Remember the graph of cosine? Since this is just a cosine and there's nothing in front, the highest or the lowest cosine will go is -1. And we know cosine is going to look like this. So the answer here does not exist. Another way to check that is if you just grab your calculator. I believe it says undefined. It might just say error. Well, let's just check that. Okay. I want to do the inverse. I wanted to move cosine over, so I'm doing the inverse of cosine, and I want -4. And you can see domain error. So undefined error does not exist. That means the only answers we have are 90 and 270. That's where cosine is equal to 0. So this would be considered an extraneous solution if a number came up, but it creates a false expression when checked. All right. What I'm going to do with this next one is we're actually not going to solve it. I feel like you guys hopefully are comfortable with the solving part here. It's just I want to show you other methods that we can factor so you're just more aware of that. So maybe don't even write this one down. Actually, maybe you want to. This is our last problem. So it's up to you if you want to write it down or not. But notice there is a different here. This one is definitely different. We still have to find the answer from 0 to 360, so we know our answer is going to be in degrees, round to nearest tenth if possible. But the weird part is I have a cosine and a tangent mixed together. And hopefully you're thinking, if you remember that day that we practiced all these factoring skills, and we had something like this where we had like 5 heart times a banana minus 3 bananas that equals 0. Well, we have to factor out what these have in common. What do they have in common? They each have a banana. Well, it's the same thing here. They each have a tangent. So we want you to take that day that we did all that weird factoring, and this is why, right? We're thinking, what do they have in common? Both of these items have a tangent in common. So we're going to factor out a tangent. And let's try to do this without any u substitution because I've got more than one function. So we've got 5 cosine minus 3 equals 0. So we factored out a tangent. Well, now we have the zero product property. We're going to set each factor, the tangent and whatever's in the parentheses, equal to its own 0. And then we're going to find our answer in degrees. Now, this one is kind of unique. Tangent is kind of difficult to think of. So here's what I'm thinking is, remember, tangent is sine of x over cosine of x. And if I want tangent is equal to 0, we could think of it as dividing by 1. So I might create a little thought bubble here just because this is where my brain goes when thinking about a problem like that. So the question then isn't when is tangent equal to 0, but when is the sine is the y value, cosine is the x. When I'm looking at my unit circle, those are on the quadrantial angles, and I know the location of each point, right? Go over 1 up 0, go over 0 up 1, negative 1, 0, and 0, negative 1. So now the question is, when is y equal to 0? Well, y is equal to 0 here and here, but when is x equal to positive 1? And that's only one location. And that's right here at 0 degrees. So I know that this answer here is x equals 0. And I don't have to think of any other reflection point, and the reason why is the only other spot where y is 0 and x is 1, well, there actually isn't one, right? Because this is when x is negative 1. So this only has one answer. Okay? And then the second factor we have to solve. So cosine, if I move the 3 over, that'll be a 3, but then I'd have a 5 here, right? A 5 times cosine. So instead of writing that, I'm just going to divide. I'm going to move the 3 first and then divide. Now, 3 over 5 is not a familiar fraction, right? That's something that is not on our unit circle. So I'm going to bring cosine over, and I'm going to do this in my calculator. So I'm already in degrees mode. If they had, let's say they wanted this answer in radians, then I would have to change my mode, and you have to be aware of that. If your answer is in degrees, you want degrees. If your answer is supposed to be in radians, you got to change it. So right now I'm currently in degrees mode. So I'm going to go second cosine, and I wanted 3/5. So 3 divided by 5. Enter, and there's my answer in degrees. But as we know, we're not done. I know that's one of my answers. Round that to the nearest tenth. There's one of the answers. However, where else is cosine positive? Remember, cosine is the x value. So when is the x value positive? Anytime we move to the right. So then all I would do is take this 53 degrees and reflect it down here. And my reference angle is 53 degrees, 53.1. But I don't want that answer, right? I want the answer between 0 and 360. So I got to go all the way around and do 360 minus 53.1. Now, some students are thinking, do I have to draw that? No, if you can know all this in your head, you don't have to show any of this work, right? You can just do it. And the answer here is 306.9 degrees. So I've got one answer from the first factor. I've got two answers from the second factor. All right, I can kind of envision this being a more challenging delta math today. And the reason why is you might find an answer for one and forget about the answer for other quadrants. So you really need to think about if it's cosine, it's the x values, and if since this is a positive value, cosine is positive in these two quadrants. Okay. Okay. I am going to show you one thing here quick that could be helpful, could be very helpful. And I don't know if you want to write this down or not, but this is just a very quick review of the unit circle. Okay. You know what? Let me use my technology. So here's what I think is coming out of pre-calculus, going into calculus. If you can have these items kind of memorized, you're in a good spot. We have this spot right here, which is the long distance, so that's square root 3 over 2, and then up 1/2. So it's more probably right there. Okay. Now that angle is the 30 degrees or pi over 6. Okay. If I go exactly halfway through that, okay, perfectly halfway through, we get square root 2 over square root 2, which is 45 degrees or pi over 4. Pi over 4, not 6. And then the last one is if I go over half the distance here and then up the tall way, that's 1/2 square root 3 over 2, and that is 60 degrees or pi over 3. So you need to have those items memorized. You also need to know that the x value is cosine, right? And the y value is sine. But then you also need to think about, well, tangent is sine over cosine, right? Or as we talked about it, y over x. And then just know the location of the quadrantial angles. All right? And really, that's it. If you know all of this, you can do reflections on all the other pieces. But I want to show you one last thing. So remember, sine is the y value, right? And cosine is the x value. So if I have a cosine, cosine is going to be positive here and here, because cosine is the x, right? So if I move in the right, cosine is going to be positive in quadrant 1 and quadrant 4. The sine value is going to be positive when the y is positive. So sine is positive here, and anytime it's above, sine is positive here. Okay? And then when is tangent positive? Well, tangent, everything is positive in quadrant 1, but tangent is positive when sine and cosine are both the same values. And since sine is negative here and cosine is negative here, that means tangent is positive. So I don't know if this helps with knowing where your answers are going to be, but that's kind of how I think of it, and it all is based off of the x and the y values. All right, what I want to do is just send you a quick link. If you did not watch the video from Wednesday, I just sent it in there. That should be part of what you're doing tonight to get caught up from yesterday. And then the homework tonight is 5.1 and 5.2 day 2 in Delta Math. And it should be available now. I think I had it released at 9:45 today. That's all I have. We're done a couple minutes early. If you have any questions, please stop into my office hours and see me. Otherwise, have a great day. Adios.